For us as human beings, time feels personal and immediate. We sense it through the ticking of our heartbeat, the rhythm of our sleep-wake cycles, the pace of our aging, and the way a joyful hour can vanish in a blink, while a painful minute can feel endless. This is psychological and biological time, subjective, elastic, and tied to our own perception. Yet when cosmologists speak of time, they mean something very different. Cosmic time, the uniform clock ticking since the Big Bang, now about 13.8 billion years. Against that grand scale, our entire lives, compressed into 70 or 80 years, are less than a blink in the universe's story. Isn't it humbling to realize that what feels so long to us is nearly nothing from the universe's perspective? Einstein deepened the mystery by showing that time itself is not fixed but relative. A person traveling close to the speed of light experiences time more slowly than someone at rest, a phenomenon called time dilation. Similarly, a clock near a black hole ticks more slowly than one far from gravity's grip. This means that even human time is not universal. Two twins, one who stays on Earth and one who travels near light speed, would return to find that they have aged differently. Doesn't that overturn our everyday intuition that a second is always the same second everywhere? If we zoom out further, we meet galactic time. The Sun takes about 250 million years to orbit once around the Milky Way. That means in all of human history, we have not even completed a fraction of a single galactic year. Galactic rhythms move in cycles far beyond our imagination. Compared to them, a human lifespan is less than the tiniest fraction of a day. If Earth's history were compressed into one galactic orbit, all of civilization would fit into a sliver at the very end. Doesn't it make you wonder what long really means? Now shrink the lens instead of expanding it. At the atomic scale, electrons jump between states in femtoseconds, and nuclear interactions occur on scales of 10 to 22 seconds. These intervals are so tiny that for them, even the blink of an eye is an eternity. To atoms and nuclei, our seconds are vast oceans of time. Imagine a whole drama of billions of events unfolding while you sip your coffee. It is happening constantly at the microscopic scale. Neutrinos complicate the picture even further. These ghostly particles change identity in microseconds. Yet, because they interact so rarely, they can travel across light years of matter as if nothing were there, almost eternal in their stability. In them, we see a paradox: ultra-fast oscillations married with almost timeless lifetimes. What does it mean for time to be both fleeting and enduring, depending on which property you look at? The truth seems to be that time is not a single universal stream, but a hierarchy of scales, each valid in its own frame. For us, moments are measured in seconds to decades. For galaxies, cycles stretch into hundreds of millions of years. For atoms and particles, time dissolves into unimaginably quick flickers. And yet all of these clocks tick within the same universe. The paradox is that no one scale is more real than another. Time is always relative to the process that defines it. For the cosmos, we are gone in a flash. For an atom, we last forever. So we are left with a haunting question. Is time a real flowing river binding all scales, or only a convenient illusion, tailored to the observer and the rhythm of matter they choose to measure? For humans, time is lived as a combination of biological and psychological rhythms. Our circadian clocks align us with the day-night cycle, while heartbeats and breathing define shorter internal intervals. Aging provides the longest biological measure, stretching across decades. Psychological time is subjective. Moments of joy seem to pass quickly, while boredom makes seconds feel endless. This human-centered sense of time is local, embodied and deeply personal, yet it is just one layer within a much larger hierarchy of temporal scales. Waiting in a hospital room can feel endless, though the clock shows only minutes have passed. Human time is like watching a movie. Sometimes the scenes fly by, sometimes they drag, but the reel keeps turning. Cosmic time is defined as the age of the universe since the Big Bang, measured in billions of years. It provides a universal clock, used in cosmology, independent of individual perception. Unlike psychological or biological rhythms, cosmic time flows uniformly across the expanding universe. In this frame, galaxies evolve, stars are born and die, and cosmic structures form. Human lifespans vanish into insignificance compared to these spans. From the cosmic perspective, our existence is a blink. The universe is about 13.8 billion years old, while an average human life lasts less than 0.000000001% of that time. It is like comparing the flutter of a butterfly's wing to the turning of Earth around the Sun. Einstein's theory of relativity teaches that time is not absolute, but relative to motion and gravity. A clock moving near the speed of light ticks more slowly compared to one at rest, an effect called time dilation. Similarly, a clock deep in a gravitational field runs more slowly than one far from massive objects. This means two observers can disagree on how much time has passed, and both be correct. Even human time can diverge depending on where we are in the universe. Time is elastic, woven into the fabric of spacetime itself. Astronauts on the International Space Station age a tiny bit slower than people on Earth, due to both speed and gravity effects. It is like stretching a rubber band. Depending on where you pull, the spacing between marks changes. Galaxies operate on timescales that dwarf human history. The Milky Way rotates once every 250 million years, a galactic year. During this time, entire species rise and vanish on Earth without completing one orbit of the Sun around the galaxy. Stars follow cycles of birth, fusion, and supernova death across millions to billions of years. Galactic time measures epochs and cosmic evolution rather than moments. Human lifespans are too short to perceive these vast rhythms directly. When the dinosaurs roamed Earth, the solar system was in a completely different position in its orbit around the Milky Way. It is like comparing a single heartbeat to the turning of a great wheel that takes centuries to complete one revolution. At the atomic level, time operates unimaginably fast. Electrons jump between energy states in femtoseconds, or 1/1,000,000th of a billionth of a second. Nuclear interactions occur even faster, on scales of 1022 seconds. These durations are so brief that human intuition cannot truly grasp them. Compared to this, a human second is an eternity. Atoms and nuclei exist in a time regime where processes occur billions of times within our simplest actions. A photosynthetic reaction in a plant involves electron transfers completed in less than a trillionth of a second. It is like an insect flapping its wings thousands of times while we take a single step. Subatomic particles reveal paradoxes of time on even stranger scales. Neutrinos oscillate between different flavors in microseconds, yet their stability allows them to persist for billions of years. Some unstable particles, like pions, decay in trillionths of a second, while protons may live longer than the age of the universe. Thus, particle physics combines the shortest known lifetimes with the longest imaginable stability. Subatomic time compresses and stretches beyond ordinary intuition. It challenges our very definition of duration. A muon produced in cosmic rays decays within microseconds, yet can reach Earth from space due to relativistic time dilation. It is like watching fireworks. Some sparks fade instantly, while others glow for what seems an eternity. Time is not singular, but exists in layers across scales. At the human level, we measure seconds, minutes, and years. At the galactic level, cycles are hundreds of millions of years. At the atomic level, processes unfold in femtoseconds or faster. These timescales coexist in the same universe, each valid within its frame. The meaning of a moment depends entirely on the system we observe. While you blink your eyes, billions of atomic transitions occur and galaxies continue their slow revolutions. It is like different clocks all ticking at once. Wristwatches, pendulums, and cosmic orbits, each correct in its own domain. The paradox is that all these timescales exist simultaneously, yet none is more real than the others. Human lives are flashes against cosmic time, but from the perspective of atoms, our seconds are endless. From galaxies' view, civilizations rise and fall before one orbit is complete. No single clock defines the universe. Time is relative not only to speed and gravity, but also to scale. Existence is a mosaic of temporal frames woven together. To an atom in your body, your lifetime contains more oscillations than the number of stars in the galaxy. It is like a symphony where each instrument plays at its own tempo, yet all are part of one composition. All these views raise the profound question, what is time itself? Is it an absolute flow, or merely a measure of change tied to the observer and process chosen? Physics treats time as a coordinate of space-time, yet human experience makes it feel like a river flowing forward. Perhaps time is not a single thing, but a construct emerging differently at each level. Its relativity and multiplicity may be its true essence. The reality of time remains one of science's greatest mysteries. Einstein said, "The distinction between past, present, and future is only a stubbornly persistent illusion. It is like a kaleidoscope. Turn it slightly and a completely new pattern of time appears, all equally real,